Folks. Hope you're doing well. In the last video, we learned about some soil basics and its representation via a phase diagram. We also looked at some basic definitions like water content, void ratio, and porosity. Continuing on that, today we'll study saturation, unit weight of solids, and specific gravity of solids. So, without any further delay, let's start. So if we quickly recap the three-phase diagram and the definitions that we learned, we recall that we have the three-phase diagram consisting of air, water, and solids. We have the volume on the left side, the weight on the right side. We have the volume of air, water, and solids. And the volume of air and water is called the volume of voids together. And on the right sides, we have the weight of solids, weight of water, and weight of air. The weight of air is taken as zero for all practical purposes. And then we also talked about three important definitions. We talked about water content, the void ratio, and porosity. The water content is represented by a small w, and it's equal to the weight of water over the weight of solids. The void ratio is represented by an E and is equal to the volume of voids over the volume of solids. Finally, porosity is represented by an N and is equal to volume of voids over the total volume of soil. So these three were the important definitions that we discussed in the last video. And now in today's video, we'll look at saturation, unit weight, and specific gravity of solids. Now, these are the other three important definitions of soil mechanics, which we'll be using again and again. The saturation is represented by Ns. The unit weight of soil is usually represented by gamma. And the specific gravity of solids is represented by Gs. Let's start with saturation. Saturation is represented by the symbol S, and saturation represents how much of the void space is occupied by water. So if we look at the three-phase diagram here, we have solid, water, and air, and this is the void space. So how much of this void space is occupied by water? So if this void is completely filled with water, let's say there is no air and then there is only water, then we say that the soil is completely saturated. And if this void is completely filled with only air, then we say that the soil is dry since there's no water. Mathematically, saturation is equal to the volume of water over the volume of voids times 100 if it's represented as a percentage. Now there are three scenarios. The first one is, let's say it's completely filled with water. So if the void is completely filled with water, then we say saturation is 100%. Usually this is the case when there is a lot of rain, and in case of clays, the soil may have voids which are completely filled with water, and S is equal to 100% in that case. Next case, it can be like in a desert. We can say the soil is completely dry. Then what happens in that case is saturation is 0%. But these are like extreme cases, and usually saturation lies between 0 to 100%. So S is less than 100%, is greater than 0. So that is the typical case that we usually have in soils. So S equals to VW over VV is an important relation which we should memorize. Let's try to understand what saturation means with the help of an example. So let's say we have 100 cc of soil, and we are given that the volume of solids is equal to 50 cc, the volume of water is 20 cc, and the volume of air is 30 cc. And let's say we need to calculate what is the saturation of the soil, or how much the soil is saturated. In other words, how much of the void space is occupied by water. So if we fill up the three-phase diagram on the volume side, we have the volume of air which is 30 volume of water, which is 20, and the volume of solids, which is 50. We know that the air and water add up to form voids. So what's the volume of voids? Volume of voids is equal to 30 plus 20 equals to 50. So the formula of saturation was volume of water over the volume of voids. So if we plug in all the values, we can see volume of water is 20 and the volume of voids, that's 50. So this is 0.4. In other words, we can say that the saturation of the soil is 0.4, or the soil is 40% saturated, which means that if this is the soil and this was the void which we were looking at, this means that the void is 40% filled with water. So that explains a very simple example of what saturation is. Feel free to comment if anything is not clear, and I'll be happy to address that if there's any doubt or any confusion. The next definition, that's the most important of all the definitions, is unit weight. Unit weight is represented by gamma. It is defined as the weight of soil per unit volume. Unit weight is somehow related to density, because density is also a ratio of weight over volumes. So as I said, it's the ratio of the weight of soil per unit volume. And depending on the state of soil, there are mostly four types of unit weight that we consider. We have the bulk unit weight, we have the dry unit weight, then there is saturated unit weight, and finally we also have effective unit weight. The bulk unit weight is called gamma or gamma T. The dry unit weight is called gamma D. Saturated is represented by gamma sat, and the effective is either represented by gamma dash, or it's called gamma buoyant or gamma B. To understand unit weight better, let's have a look at the three-phase diagram which is given here. So bulk unit weight is simply the total weight of soil over the total volume of soil. So gamma equals W over V. And since in this case we have all the three phases, this should be equal to weight of solids plus weight of water over volume of solids plus volume of water and volume of air. So simply the total weight of soil over the total volume of soil. Now the SI units of bulk unit weight are kilonewtons for the weight and meter cube for volume. So it's kilonewton per meter cube. And the imperial units of unit weight are, for weight we have pounds, and for volume we have cubic feet. This is pounds per cubic feet, or which is also represented by PCF, pounds per cubic feet. Next, we have dry unit weight. Now, dry unit weight is used when water in the soil is absent. In other words, we have no water or the soil is completely dry. So it's just a two-phase system of solids and air. So the gamma dry in this case is weight over volume, and in the weight we just have weight of solids because weight of air is 0, and in the volume side we have the volume of air and volume of solids, right? So this is for the dry unit weight. Next we move on to the saturated unit weight. So it's just in this case we again have the two-phase system, but as we all know, saturated means there is no air. It means the saturation is 100%, so the voids are completely filled with water. So again we just have the two phases, the solids and water. So the gamma sat in this case is equal to, we have the weight of both of the components, which is weight of solids plus weight of water over the volume of solids plus volume of water. Finally, we have the effective unit weight. Now, effective unit weight is only when the soil is submerged. Let's say we have the water table here, and which is represented by a small triangle and three lines. So and we have the soil here which is submerged under the water table. So in this case, a buoyant force acts on the soil, which reduces the unit weight of soil because of the water displaced by the solids. So this is the Archimedes principle. So according to that, we have the effective unit weight of soil, which is represented by gamma prime, and this gamma prime or gamma dash is equal to gamma saturated minus the unit weight of water. Now the unit weight of water is usually constant and is taken out to be 9.8 kilonewton per meter cube, which means that 1 meter cube of water has a weight of 9.8 kilonewtons. So this is the definition of effective unit weight, and effective unit weight is mostly used in calculations involving water table. Finally, we move on to specific gravity, which is represented by Gs and is also defined as relative density. So relative density means how heavy a material is with respect to water. So water is used as a base to see how heavy other materials are. So if we assume that the density of water equals to 1 gram per cc, which is pretty much standard, then the density of soil is found to be in the range of 2.6 to 2.8 grams per cc, or in other words, Gs is equals to, like if we take the ratio, 2.6 to 2.8. This is very important and we should try to memorize this. The lower limit is usually for sandy soil and the upper limit is for clayey soils. So mathematically, Gs is the ratio of weight of solids to an equivalent weight of water. Gs equals to weight of solids over weight of water. Now weight of solids is gamma S times volume, and this is gamma W times volume, and since volumes are equivalent we can cancel those out, which leaves us with gamma S over gamma W. And since it's unit weight, we can cancel out acceleration due to gravity, and it's just the density of solids over the density of water. Since density of water is taken to be 1 gram per cc or 1, the Gs comes out to be numerically equal to the density of soil. So as we said, we should remember Gs lies between 2.6 and 2.8. For sands, the general value, acceptable value of Gs is 2.65, and for clays, the Gs is taken to be 2.7 or 2.70. These are very important relations which we should memorize. Let's try to briefly summarize all the important definitions of soil. So we have 6 important quantities: water content, void ratio, porosity, saturation, unit weight, and specific gravity of solids. If we look at the three-phase diagram, we have air, water, solids. This is volume side, weight side, VA, VW, VS, WW, and WS. Now, water content is weight of water over weight of solids, which is essentially the ratio of this over this. Void ratio is VV over Vs. N is VV over this total volume V. Saturation is defined as how much void volume is occupied by water. So if this is the void volume, so saturation is volume of water over volume of voids. Then coming to the unit weight, we have unit weight is simply the total weight of soil over the total volume of soil. Finally, specific gravity of soil can be written as the unit weight of solids over the unit weight of water. These all are very important relation which we should try to memorize, and this completes the lecture. If you guys gained something from this video, please remember to like, and I'll see you in the next video.